My please. Good morning. I think I can hear you now.
Oh, okay. It's afternoon here. Sorry.
Oh, okay. Oh, right. Yeah,
Yeah.
it's almost afternoon here. It's just a minute before afternoon. So good afternoon.
I had this confusion. Last week I was up till a week about some days ago, I was in Nigeria. So when I saw, oh, last week I wasn't there, today I have to be there. And by 12 o'clock I logged in and remember, oh,
I understand how it can be.
yeah.
Yeah,
It's,
so I've been.
yeah, it gets confusing all the time. I'm sure it's going to change over time. So,
Yeah. Yeah, so how have you been? How's everything? How was your flight? I didn't know that you were in Nigeria. I would have probably
oh, really?
reached out to meet.
It's been maybe I'll apologize when everyone is there. It's been a crazy set of
Yeah.
things. I had to do a lot of rounds, and usually when I'm in Nigeria, I'm either coming to take some time off from all the
I
work,
understand.
but then it wasn't as restful as I thought it would be. So eventually,
Yeah.
I had to just swing back to work. So
Yeah, I understand. I understand how stressful it can be. So without much ado, I know Dennis wants to take us up now. So I
yeah,
wouldn't want to take much of your time anymore.
no, it's not a problem. Thank you so much. It's so
Yeah,
nice to get to speak with you.
yeah, of
All
course.
right.
All right.
Good morning, sirs. Good morning. Good morning, Mr. Ridwan. Good morning, Mr. Gabriel. And good morning, everyone. I trust we're all doing great today. Welcome to class. Thank you so much, sirs, for joining us. And thank you to our mentees who are already on call. You're all welcome to week 4 of our JIIPCC mentorship and internship program. We are come so far in such a little time. The week seems to just be flying, but then it's always great to have us in this particular class, the artificial intelligence and technology class. So not to waste any other time, right, I would like to just take an announcement so that we can start the class proper. Mr. Gabriel and Mr. Ridwan have already started the engagement, and we hope that it is just going to get better from here on. So moving on, so taking the announcement, JIIPCC Academy, right, is it's hosting a free legal clinic for creatives, entertainers, athletes, innovators, and startups. We came about this initiative to help those who are seeking some form of legal counsel for free, right, and who want to resolve disputes, who have particular disputes and issues that they need legal advice or legal counsel on, and JIIPCC is offering the opportunity to have a 20 minutes consultation with our professionals. So we have a list of professionals who are willing to offer professional legal counsel as regards a host of matters and disputes. So if you are interested in right, in benefiting for that, or you know someone or have people around that may need some form of legal counsel and may not necessarily be at the moment able to add to to have access to to have access to a legal to be able to pay for legal services. JIIPCC is giving this opportunity. You can kindly reach out to me, and I will do well to give you more inputs and information about that. And sorry, I forgot to introduce myself. My name is Dennis Williams, and I will be your moderator for today's class. Right. So our topic for today is robotics and oversight, and we have two mentors who are already on the call. They are willing and they are ready to take us through on the journey today. And I'm sure this is going to be a very, very insightful class. We've talked about different aspects of AI. We've talked about utilizing AI for to overcome socioeconomic challenges. We talked about ethics in AI. We've talked about AI governance, and then we've also talked about the EU Act and the likes for the past 3 weeks. So moving forward, like I said, our topic for today is robotics and oversight. And for today's class, our mentors are going to be Mr. Ridwan Badmos, right, Mr. Ridwan Badmos and Mr. Gabriel Udo. I'm not going to read Mr. Ridwan's profile. We've done that over the last couple of weeks, same as Mr. Gabriel. So I will not be spending much time reading profiles, but just to welcome them. Thank you so much, sirs, for joining. We are happy to have you in our midst. So moving forward, I would just want to give the floor to our mentors to just give perspective to the topic for today. Like I said, the topic for today is robotics and oversight. And in 20 minutes, if it's going to be possible from both mentors, we'd just like to hear from you. So Mr. Gabriel, I think over to you first, then we'll receive a 20 minutes presentation from Mr. Ridwan.
Okay, thank you so much. I hope everyone can hear me.
Yes, sir, we can hear you, sir.
Yeah, my voice is a little bit still on holiday, so I hope it gets back in. First of all, let me apologize to everyone for the last 2 weeks. It's been quite a lot. I had to do a lot of traveling and eventually found myself in Nigeria. And I came back maybe due to the temperature differences and so on and so forth and the stress. I landed myself, I needed some medical attention. I'm okay, but still haven't had enough time to work at the pace I would like to work. So today at first I thought I wouldn't be able to attend. Then for some reason I had to just gather out myself and thought, okay, it's already been 2 weeks. I can't skip this week again. So thank you so much, Mr. Rewarding, for always for holding the fort when the absence, because I learned you've always been here, and it's really nice to hear that there's a lot of support, especially in this art class. So today we are going to be spending a lot more time, or I feel we should spend a lot more time, not understanding the basics of robotics, right? But looking straight at the impact it has on society. Because most of the times we have conversations around robotics and robots and AI and automation and all, we tend to look at the subject of the technology itself. And so eventually, even with the understanding we have of the technology, it seems that we can't really grasp how it impacts society to a very large extent. So I looked at the questions. I got the questions yesterday from Sophie that were asked, I think 4 of them. And then I looked at the presentation. I'll try to avoid giving too much information into the presentation. I would like to hear the presentation subsequently, and then we could make additions to it, answer questions that would come. So for now, I'm just going to give, first of all, look at the idea of robotics generally. Just not sure I'll take up to 20 minutes. And then we'll just talk for a few minutes about the examples, look at the impact, and so on and so forth, right? So I scribbled down some notes, some things that are important to note in the conversation, right? So I'll just touch things here and there, and then we'll leave the floor for the presentations, and then if there are questions, we could also take them. First of all, when we talk about robotics, I want to be under the presumption that most of us have heard or have read about the Isaac Asimov that talked about the 3 laws of robotics. These are the basis of understanding of, in the conversation between the impact of robotics and why we need to have oversight over robotics. And these 3 laws, I just wrote them and I put them just beside my table. So always when I want to start talking about robotics, I'm like, okay, the 3 laws. So I try to keep my conversation within these laws. These laws are getting outdated, I think, but they are still important towards the foundational knowledge of what robotics actually is. And those 3 laws are, maybe you could look at them briefly at your time. A robot may not enjoy a human being. That's the first thing. It's longer than that. So the second one is a robot must obey orders given to it by human beings, except where such orders would conflict with the first law, right? And then the third law is the law of self-preservation that humans have, and we try to transfer it to robots. A robot must protect its own existence. Now, but that protection must not conflict with the first or second law, right? At some point, maybe we'll get to look into that, but I wanted us to have this at the back of our mind. So in the conversation, we can keep making references to it. So what are robots? Let's start with that before we go into robotics. Robots are they are machines, so to speak, that they are capable of carrying out tasks. That's the simplest understanding of what a robot is. A machine that can carry out specific tasks. Sometimes it's autonomous, sometimes it's semi-autonomous, or sometimes it's even automatic. That's a deeper understanding. But we need to understand that using, with a combination of sensors, what we call sensors, and then there could be actuators, and algorithms, just like we have with artificial intelligence. It's very important to have certain set of algorithms um, to be able to control the robot or to give instructions to a robot as to what tasks it's to carry out, right? So there are different types of them. We have robots that range from industrial arms in factories. If you go to many factories, especially car manufacturing factories, I'm sure you may have seen this a lot of the time.
Sorry, please, is it from my hand? The network is bad.
Sorry, I didn't get that. Can you say that again? I didn't get that. Is that a question?
All right. No, he was asking. I don't think his network is so good. But Mr. Ahmad, please, can you kindly log out and join in? I think your network is one. It's an issue.
Okay, maybe the net. Yeah. All right. So I was saying that robots could vary. There are many, just so many of them. I know usually when we hear of robots, we think about humanoids, the robots that are created in the form of humans, that have a structure or something that looks like a human being, stuff like that. But there are robots that are just maybe robotic arms. If you look at car manufacturing factories, you'll see arms that are used to carry out very heavy stuff. Um, and you also have robots that as small as vacuum cleaners in the house. Those are very common in many homes in Europe. You see some automated robots that are just stuck in the corner of the house. When it spills something in the house, it goes around and cleans it and gets back to the corner and gets up. So those are also considered robots. There are other very high level robots, right? We'll talk about Sophia subsequently. Maybe may just mention them in passing. The Sophia, the Spots, those robodogs, and so on and so forth. But then at this point, it's important, like I mentioned earlier, there's a difference between AI and robotics and robots, basically, right? Many times I hear the conversation and people mix them up. In as much as at most instances, robots are automated, right? AI is just the software that powers that decision-making capabilities of a robot. Right? So there's definitely going to be a software that gives its direction as to when to lift an arm, when to lift a car, when to drop it, when to pick up one metal, when to drop it, and so on and so forth. So it's that software that is most likely going to be automated, or in many instances, artificial intelligence. It helps them to learn from data. I'm not sure why my camera is glitching from here. I hope it doesn't just go off completely. Okay, so AI is more like the software that enables that capability, right? Makes them learn from data and make many times independent or autonomous choices. But robots are like the physical entity, right? What your car mechanic would call the scrap. Robots are like the scrap, the physical structure that is used to carry out that activity. So if you have a software, it's like having a brain with no body, right? So the body is the robot. The brain or the intelligence, so to speak, is the AI. Okay. So when we integrate AI into robotics, we get what we call intelligent robots. And we are going to look at a couple of them. The first example that I normally enjoy looking at is Spot. Spot is a robot that was built by Boston Dynamics in the US. It's been there for quite a while. It's like a dog. It's capable. It's used for many things. It's used even in construction, in mining, even healthcare. Right? It's used in disaster areas to access unsafe areas. So there's an earthquake somewhere and some buildings have collapsed, and you're not sure about the integrity of the remaining parts of those buildings. So you don't want a human being to get in there and get stuck, or the space is so small that you can't get a whole human being. Or the terrain, maybe people are stuck somewhere and the terrain is so bad that you can't get a human being over there. Many times they've had to use sport. And then or we can also use them to collect data in environments. Let's say we suspect a volcano and they want to collect data from these places. So instead of having people go there and get stuff, to send robots like Spot. Then there's also Sophia. Sophia is a humanoid. I mentioned it briefly. Was built by, I think, Hanson Robotics. And funny enough, Sophia has, I think, since 2015 or so, been granted a Saudi citizenship. Something that is very, very funny. Sounds very funny to me because for countries where some humans were not allowed to drive cars up till recently, women were not allowed to have driver's licenses, and a robot was given, certain advantages that I'm not sure human beings would have in certain instances. So these are examples. There are many others. There are warehouses where you have Kiva. Kiva is built by Amazon. They are used for they are used in warehouses and manufacturing areas. So it helps. They move around very efficiently, and they help to reduce labor costs. That's what Amazon said. There's the surgical system that is called Da Vinci. Yeah, it's like a robotic surgeon that carries out some very minimal surgeries, not the very complicated ones, at least so far. So there are many and many of this. We look briefly at robotics in the workplace. In this century, especially, we've had a continual intrusion of technology, not just robots, technology in the workplace. In the early 1900s, we started having humans looking for ways of easing to reduce the workload. Even in armed conflicts, we've had soldiers, people, armies building robotic armies instead of sending human beings to the war front, send robots over there to reduce the loss of life and to also increase the capacities of an army, right? That's basically this is because robots have certain advantages over human workers, and this is something we have to keep in mind. The advantages are the example in manufacturing, a human worker will get tired at some point. You can't work 2/7. But some robots, where there's the proper fuel or the proper battery or proper electricity, anything that powers them, then it can run for as long as, so there's going to be higher productivity. There's going to be less errors in many instances, as long as that activity does not have to do with specific kind of reasoning or emotional decision making that can only be done definitely by only human beings. So they are now in agriculture, we have autonomous drones. We have autonomous tractors even now. I saw one 3 weeks ago in Lyon, in France, that is used for farming. They use it to optimize crop yields or something like that. There's precision farming or spraying. They use drones to spray insecticides or fertilizers, and so on and so forth. In logistics now, we have robots that help in packaging in warehouses, right? And now we're getting to the point where autonomous vehicles are making deliveries. I've seen videos of that. I've not seen that, physically, not yet. But from where I sit, I think the capability is already here. If it's not, it has not already happened, then maybe regulations are holding it from happening. Right. Now, while there are efficiencies, there are advantages to this. There are disadvantages also. We could talk about job displacement from now till tomorrow, because I mentioned this in one of our sessions. When I first came to Germany some years ago, I think the first couple of months, I happened to work in a warehouse. We all do, of course, or most of us do, for I think 2 or 3 months. And when I got to that warehouse, I realized that 90% of those that worked in that warehouse were immigrants, right? They were students. And there's nothing demeaning about that. There's nothing degrading about it. Over time, after some time, I left and got myself sorted out and settled in. And I got the news that this was an Amazon warehouse, that Amazon is trying to automate the workplace completely. So they got in robots. And the job that we could get over 450 people to do per shift they could get 10 robots to do even more, 10. And this was the testing phase, right? Because you can imagine how much load you can carry as a person, how many packages can you fold in 1 minute. A robot can do 10 times what you can do in less than a minute. So with these, my imagination went at the time, and now the figures really show that that's why you hear lots of job losses from the very minimal, workplaces like that to what we now use AI for, automation. Most of the visual language models are taking over jobs. I went to a law firm 2 weeks ago, and I was talking with a lawyer in Nigeria about how maybe getting a small language model could help hasten their processes, help them with filing, help them with documentation. And then the very senior lawyer, he made one comment that made me regret giving him that idea. So yeah, in that case, I don't need a secretary, and some of these young lawyers should go, right? So the idea is, okay, if I can automate this, I don't need to spend paying people to do it. Now, so we're going to have lots of that. They are in manufacturing, in retail, in transportation, in healthcare. In transportation, once we have fully autonomous delivery vehicles, we don't need a human driver. You're going to see thousands of companies just flip into those vehicles as long as regulations allow them. So the main question is, how do we balance this? How do we ensure that this balance is part of the oversight? We ensure that we keep someone watching them first from having this negative impact. We can also look at the risks of robots. This is especially when you talk about oversight, the first thing that comes to your mind is what risk should we consider? What could happen? What happens if a robot harms someone? The issue of responsibility, the issue of accountability. So how do we regulate them to ensure that the risk is minimized, right? And its capacity to cause certain disruptions to society are minimized. We talked briefly about accountability in autonomous robots. Now we're talking about autonomous robots, not just robots that have, very high level human oversight. Who do we hold accountable? Is it the manufacturer? Is it the user? Or the robot itself? Of course, the answer is already obviously not the latter. You can't, I'm not sure there's any law yet that allows a non-human agent to be held accountable for any kind of accident or for any activity or inactivity. I remember there's been an issue with Tesla's autopilot. It's been involved in many high-profile accidents in recent times. Some of them have even been deadly. People have died. Now the question is, in this circumstance, who do you hold? Are you going to hold Tesla? Are you going to hold the user for not paying attention? Because sometimes when you tell somebody this car can drive itself, he gets into the car and slips off, and it's like, I was told it could drive itself, and forgets that there's still need for oversight to be sure that what it's doing is the right thing. Or is there going to be a time where we can hold the robot responsible? Right? Again, I've mentioned it before, there's no legal framework so far that recognizes robots as an independent entity. So responsibility will definitely go to the humans involved. Then we'll now have to define whether it's the manufacturer or the user, depending on the circumstance. I think I should also mention very quickly the lesson in oversight. Why do we need an oversight? And one of the easiest examples is the Boeing 737 MAX disaster that happened some years back, right? It's not a robot in a traditional sense, but the aircraft was fully reliant on an automated system that they call the MCAS, maneuvering characteristics augmentation system. It was designed to prevent that aircraft from stalling in flight, right? But there was a design flaw, and that design flaw, unknown, so they said, to the pilot, caused two very fatal crashes. I think they killed about 346 people involved, or even more than that. Now, Boeing did not inform those pilots about the system, the problem. So it did not tell them that there's need for a certain level of oversight. Then that the software relied on that faulty sensor data. So it caused the plane to just dive uncontrollably, and the pilots were what do? There was need to override the system. And there were issues also with the system that could be used to override and give the pilots back authority over that system or control over that system. So these are one of the dangers of over reliance on robots. We've had robotic accidents in many warehouses. Many times it doesn't make the news, but of course we know they're always there. There are times that the robot is trying to pick up something and grabs a human being, maybe crushes a human being's arm. You hear people lose their jobs because they got their arm lost or stuck in a machine. Sometimes it's a robotic system. So there are many instances like that, but there's need to have proper safety checks for purpose of transparency and accountability. If something goes wrong, who do we hold responsible? Who was supposed to hold the system? Who was supposed to man the system to ensure that there are checks? We also need to ensure, we've talked a lot about ethical principles in AI, and I think we should use this also in any system that has any level of automation. One of the examples is a robot. Robots are getting more autonomy, right? They are putting more capabilities into robotic systems. So there's this idea of ethics in design, right? In the process of designing robots, we need to consider what ethical principles they are that we should have, first of all, as human beings, and second, as the system in the circumstance is supposed to have. For instance, you have robots in law enforcement, right? There are police departments that use robots now for surveillance and bomb disposal, especially bomb disposal. There are issues now about privacy and the potential for misuse. So if the robot is armed, if you read more about autonomous weapon systems, you see that you can arm a robot with whatever weapon you want to. Just program it in whatever form, give it whatever instructions you want to, and it carries it out. So what if there's a misuse? In healthcare, we have robots that have to prioritize certain cases over others. They are the first responders, for instance. What makes a case, a particular patient, more important than another patient? But there's a difficulty in programming ethics into hard machines. The question has always been there in AI, in robotics. Robots can follow rules, but they do not. Morality is a little different. Ethics is different from just having either A or B. Sometimes you have emotions have to get involved, right? If someone is driving a car and is to run into an object and realizes that there's route A, there's route B. In route A, there is a baby or there's a pregnant woman. In route A, there is, let's say, an adult male who is capable of diving. The likelihood is that he's going to go to route A because there are probabilities that the adult male is likely to dive off the road faster than a pregnant woman, right? So these kind of decisions are not just ones and zeros. There are emotions are involved, certain high level reasoning capabilities are involved that only humans can carry out. So this is the same thing with ethics. It's difficult to have to see, for instance, in healthcare, there are two critically ill patients. How do you know? How does the robot know which one needs more attention than the other? How is that decision made, right? So the first solution to this is to have what OpenAI, has talked about recently, red teaming, having interdisciplinary teams like ethicists, programmers. We have to bring these people to work together to create guidelines, and we also need to balance the. This is another problem that popped into my head while I was trying to prepare. There's the idea, there's a confusion between transparency and proprietary technology, right? So transparency requires you have to show us what you have done. It's as simple as that. Let's see what's on the backside. Tell us everything. But proprietary technology, not just in technology, the idea of having proprietary, the idea of ownership, right, would require proprietary control and understanding of how a system works. So where is the line between what we tell people about our systems and what we should not tell people about our system? There are many robots that use proprietary algorithms. The company designs an algorithm and puts it in a robot and refuses to give the system card to anyone because of the capabilities to duplicate those things. So these are some of the issues that we have to look at. I could look very quickly at regulations. Right now, so far, as long as my research serves me, I've not heard of any specific regulation, binding regulation on robotics, right? They are decentralized, uses of regulations on areas like AI. Of course, we know the European Union's AI Act, and there are other regulations that deal with most forms of automation, but not basically robotics, right? We have San Francisco has banned certain use of certain technology, for instance, facial recognition technology. So if you have to build this into a robot, you're going to have it banned. There are many of those regulations that touch around subject, but so far, I'm not sure there's a law or regulation that strictly binding strictly deals with robotics. Right? There are regulations that deal with the use of drones in certain areas. In Germany, I know there are heights to which you're allowed to fly drones for safety reasons, right? Then finally, I would like to conclude by again just giving a very quick rundown of what I've said. First of all, understand what robotics are, what are the impacts in society, workplaces, and most importantly, what is oversight, which is something I don't think I've really touched it, but maybe there are questions and we'll talk more about oversight. How does a human maintain oversight over robots? When do we say that oversight is enough? Or do we just have a human being sitting there and watching the system? What if a human being sitting there does not understand the workings of that robot or does not have the capability to turn it off if there's an issue, right? These are issues on oversight we need to look at. And then the importance of having, transparency in decision-making processes and ensuring that all these are hard coded into the robot. Okay. Yeah, so this was just a rough touching around, the subjects that I think we should talk about today. I'm certain there are going to be questions subsequently. Thank you so much for the opportunity to speak with you today. And I think at this point, I'll leave the floor to Mr. Rikwan. Thank you.
All right. Thank you so much, Mr. Gabriel, for that very insightful. Okay, Mr. Ridwan.
Yeah, I'm still here. So I sent a message to Mr. Older and Mr. Dennis initially that I will have to leave because I have an emergency so at office and it's quite urgent. But then I decided to just put in some few words so that I would just leave without saying anything since I've already you were expecting me initially. So I just been put in some few words for a couple of minutes. I mean, some things I think are important for you to consider in terms of how to approach this particular space. I mean, robotics and oversight. And I think, Mr. Alba has said a lot of things, and I believe he has even covered everything. I mean, in terms of technological advancements of robotics and of robots, and even the legal and regulatory landscape. So all those areas have actually been covered, and I can't even think of any other thing to add except to say that I believe that the previous classes that we've had regarding AI, AI governance, ethical AI, responsible AI, creating trustworthy AI are going to be very, very relevant. And even all the relevant, AI laws, standards, frameworks, and the likes that, form, AI governance. And, I spoke a lot about, I'm not sure if I mentioned this, but operationalizing ethical AI through AI governance is very important. All these areas are actually going to be very useful for kind of, overseeing or creating a kind of human oversight, over robots. And even though Mr. Alba has said that we don't really have comprehensive, legal, we don't really have, comprehensive laws or regulations for robotics generally. But I believe that I think the best way to actually approach this is, through best practices, and we have some, guidelines. It could be industry-specific guidelines that can actually be used that can be adopted by different companies building, robots. And I think the other angle I wanted to, I mean, I'm not sure if this is a general thing. I mean, Mr. Ola will confirm this is more of an expert in robotics than I am. So in terms of having digital, robots as well, which are most times called bots. So you could, I think I also went through the presentations, and I mean, you did a great job in terms of at least carrying out the research, conducting research, and coming up with contents regarding that area. But then my observation is just that it wasn't really in depth. I think that's group one really. I think they did a piece of good work in terms of covering some of the legal. Even though it was general covering, I think it was just the kind of the status or the legal status or the status of the legal, the legal developments or regulatory developments in the area. But you really didn't go deep to talk about, specific regulations that might, apply to the developments and deployment of robots. So I was talking about the digital robot that might be called bots, and you really need to have, and that's the reason I love the fact that Mr. Odo, started by explaining the robotics and the technical, space, how it really works. And one of the things you really need to know, I mean, from what I was trained in terms of you categorizing robotics into should I say digital and non-digital? I mean, in terms of non-digital means physical. Most robots, or when people talk about robots, you always think that we're talking about physical robots, physical objects. But then we could have digital robots that are not in that doesn't have a kind of physical look, so to say, or a physical representation. So, and these kind of robots, and then another I think another thing you need to really have in mind is the differences between AI powered robots and those that are just those that are just powered by algorithms, or kind of algorithms that are not really built through AI models, so to say. So in terms of robots that are kind of programmed, but not through machine learning, so to say. So because I believe that these differences will also kind of will be considered when looking at the different laws that are going to be applicable to these different types of robots. So, and for you as for lawyers, I think those issues that you really need to look at in terms of legal areas has to with, I mean, I saw different questions that you put up in terms of liability and the likes. So I think that's one of the major areas that you also need to look at in terms of and I think that has to do with transparency and accountability as well, especially accountability in terms of who is going to be liable when a robot, including autonomous vehicles, impacts the society or an individual negatively. So all these things are things that I think you need to kind of look at when considering the legal issues or regulatory issues surrounding robotics. So I'm sorry, I'm not quite, because I'm kind of distracted. But then I told Dennis earlier that I'm going to come up with a presentation so that I can send to you guys. That is going to be a kind of addition to the little that I have shared. So I look forward to seeing you guys in the next class, and if you will allow me to take my leave now. Thank you very much.
Thank you so much, Mr. Ridwan. Thank you for the contributions. I'm really grateful to you. Thank you.
Thank you so much.
All right.
Have a nice day.
Thank
Bye.
you so much. Thank you so much, Mr. Ridwan, and thank you also to Mr. Gabriel for a wonderful presentation on the topic. I think in 30 minutes about our mentors have been able to give an oversight of the topic of today's topic, and we've heard from them. So now we want to hear from our mentees, right? You have done your research, you have done your research, you have done your work, we've sent it to the mentors, they have looked at it. But we want to hear from you right about now about basically just to get your own perspective on what you understand as tied to the presentation you have made. So Group 1 presenter, please, you can kindly unmute yourself and start your presentation. You have 10 minutes for your presentation, and then same with Group 2. So please, we'll start with Group 1. Group 1 presenter, please kindly unmute yourself, share your screen, and continue with the presentation. Mr. Daniel Bello.
Yes. Good afternoon, everyone.
Yes, good
Give me a
afternoon.
minute to share my screen. Good afternoon. So my name is Daniel Benlo, and I would be presenting for Group 1 on behalf of Group 1. And our presentation centers on robotics and oversight. We would be reviewing the ethical implications of autonomous robotics and the regulatory frameworks. So first of all, we need to understand what the presentation is all about. We are talking about autonomous robotics. These are robots that perform tasks independently without human control. The robotic oversight has to do with the management and monitoring of robotics in a way that it is safe, it gives good use, and the potential risks are reduced. Now, when we look at the ethical implications, these are the challenges or the potential moral consequences of using autonomous robots. We have seen in developed times, we have so many types of robots. We have so many uses for all these robots. But then, for the use of all these robots, there are risks attached to this. One of our mentors mentioned Tesla, self-autonomous driving vehicle, and the risks it give out to its users. I think for some of them got locked in their cars. They could not get out. There were so many issues that arise from all this. We have listed down to see a few of these ethical implications. We have accountability. Our mentor, Mr. Gabriel, talked about who would be held accountable for the robot's misconduct. And I think at this point, obviously, it's the creators. We have bias, we have privacy, we have job displacement. We have seen Amazon bringing in test robots to test out work fields and how robots can do better in a way to say than what humans would do. That poses a potential threat to the availability of jobs for us. We see safety, we see decision makings, the use of autonomous robots, having them work independently without human control brings so much to talk about. And then we have seen that the best way to try and reduce this is to bring in regulatory frameworks. Our mentor, Mr. Gabriel, started with the 3 laws to which robots operate. And before these laws really came into place, I think in 1942, a man named Isaac Amiso, a biochemist and a fictional novelist, was the one who started up with these rules. He brought out 4 rules. They were robots must respect or obey humans by their actions or inactions. They must not hurt humans. They must that was the first rule. The second rule was that they were to protect themselves, but not at the expense of human beings. The third rule was still obedience, and then the fourth rule was the preservation of humanity. They must not in any way injure humans or humanity by their actions or inactions. And now we'll be looking at some of the regulations for robotic oversight. We have safety standards, privacy protection, security measure, transparency. In a way to reduce the risks caused by robotics, we need to implement safety standards. This and this are how the designers of autonomous robots should work with. These are the regulations they should work with. We need a standard for safety so that our rights or us as a human being or person, we are not harmed by any way, physically, mentally, or in terms of data preservation. We have security measures in which all these autonomous robots should operate by. Accountability framework, we need to know how these robots operate. Human oversight, testing and validation, certificate and compliance. We need autonomous robots that comply with certain rules in a way that we can as well reduce the risks. We can preserve. In 2023, Elon Musk and a few AI experts, robotic industries, tried placing a pause on the development of AI and robotics with the statement, if I may quote, powerful AI systems should be developed only once we are confident that their effect will be positive and their risks will be manageable. So we've seen that it's really a global issue that with the development of autonomous robots, there are risks, and then there should be regulatory frameworks to ensure that when we start to use these autonomous robots in a large scale or on a large scale, we are confident that their effects are positives and then they do not bring negative effects or harm to us. And I would also be talking about frameworks, regulatory frameworks. We've divided them into two by the presentation. We have existing regulatory frameworks. We have the proposed regulatory frameworks. And under the existing regulatory frameworks, we have one of which is the European Union. In 2016, we had the European Union come up with legal frameworks where they try to give out rules to which robots may operate and how designers would create such autonomous robots. And some of the critical elements that were in their regulations were the European Agency for Robotics and Artificial Intelligence. We have ethical guidelines to which they were trying to, or which they enacted to try to keep robots, autonomous robots, to operate by. And then we have the promotion of research and innovations, which so this was more of a national regulatory frameworks. And internationally, we have the International Organization for Standardization, which tried to focus on safety and interoperability. And we also have industrial specific regulations. We have listed two out, healthcare and aviation. By healthcare, we see with the development of autonomous robots, we have robotic arms that are into surgery procedures, and then this poses a threat because we do not know what might go wrong in the process of surgery. Therefore, there is a need for an oversight of autonomous robotics in this area. There's a need for regulatory frameworks to know how these robots would operate in a way that we are safe and confident that the use of this autonomous robot would not pose threats to us. And when we talk about proposed regulatory frameworks, we can talk about RoboLaw. It's an European project that was set out to research and identify legal and ethical regulations to which robots can operate. This project was set out in 2012. It's still ongoing. There's still research in the autonomous robotic fields. We have proposed regulatory frameworks in the ethical and legal implications, where we see that, especially in the legal aspect, in having law firms have autonomous robots do certain tasks for them, there are very much controversies to this data privacy, biasness, job displacement, accountability, and all of such. And we can also see the effectiveness of these regulatory frameworks. We are seeing that, okay, fine, we have these frameworks, and these frameworks are here to ensure safety, non-biasness, privacy, and then a lot more of these proper decision makings by all these robotics and all. And lastly, we will talk about the challenges and limitations to the rapid development of autonomous robots. We can see balancing innovation and oversight. It's hard at this point, especially for companies to keep up with the innovations, and especially the public to keep up with the innovations of autonomous robots, AIs, and all. When it comes to being used on a large scale, most people are backdated to the use of autonomous robots. The complexity of autonomous systems, it is at most times hard to understand how they work, how they operate, how they should be used properly, and how they can be regulated again in a safe space. And we have rapid technological advancement, which bring about cost, would bring about a lot of environmental issues and so much, especially I think one of the biggest issues is cost, what it would take to rapidly develop the society, and what cost it would take to maintain the societies when and whenever these autonomous robots are being implemented. So thank you. That will be all for my presentation.
All right. Thank you so much, Mr. Daniel, for that wonderful presentation, and well done to you and your group for putting that together. We really appreciate the effort and the time you guys took to package that presentation and for a well-delivered presentation. So well done to Group 1. So please, we'll be taking presentation from Group 2, and then we'll have feedback from Mr. Gabriel. We'll take questions, and I think that will be that for class. So please, can we have Group 2 make their presentation quickly so that we can get back to Mr. Gabriel? The group presenter for Group 2, are you on call?
Yes, good afternoon, everyone. I'm trying to share my screen.
All right, thank you, Juliet. Please go ahead and share your screen.
Okay. So, good day, good afternoon, everyone. My name is Angelo Juliet, and I'm the presenter for Group 2. The topic for today is human-robot interaction, trust, bias, and fairness in robotic systems. So, understanding, we'll be focusing on exploring the evolving role of robots across industries, the importance of trust and bias in human-robot interactions, and considerations for ensuring fairness in robotic systems. So understanding human-robot interaction is crucial for designing and developing effective and user-friendly robots in various settings, including industrial, healthcare, and everyday environments. So for the industrial robots, trusted as efficient, reliable tools for safety and productivity. Human-robot interaction is essential for ensuring safe and efficient collaboration between humans and robots in industrial settings. Understanding how humans interact with robots in industrial environments helps designers create more intuitive and user-friendly interfaces. Effective HRI in industrial settings can improve productivity, reduce errors, and enhance overall workplace safety. Next is healthcare robots, trust tied to competence, empathy, and patient-centric design. HRI is crucial in healthcare settings where robots interact with patients, caregivers, and doctors or nurses or any medical professionals. HRI Healthcare helps designers develop robots that are empathic, trustworthy, and effective in patient care. If these robots they don't have empathy, they don't show care, patients or these medical professionals or practitioners would not trust them with their medical professionals would not trust them with their patients, neither would the patients trust the robots or the robots to operate on them or to even interact with them. So effective HRI, effective human robots interaction in healthcare can improve patient outcomes, reduce recovery time, and enhance overall quality of care. Next is the everyday robots. Trust hinged on user friendliness and seamless integration. So HRI is it can be seen as a vital is HRI is better in everyday settings where robots interact with people in their homes, public spaces, and daily lives. We have these smart homes right now that people oh, Alexa, turn on the light, Alexa, do this, Alexa, do that. We have that now. So understanding HRI in everyday environment helps designers create robots that are intuitive and that are user friendly and integrated into daily routines. We have for example, we have Alexa's. Oh, once we wake up, we'll be like, oh, Alexa, turn on the lights. Alexa, draw the curtains open. So by understanding this human robot interaction, designers and developers can create robots that are more intuitive and user friendly and effectively communicate with humans. So ultimately, understanding human robot interaction for creating robots that can effectively collaborate with humans and improve productivity and quality of life and enhance overall human well-being. Next is factors shaping trust in robots. We have design, transparency, reliability, and ethics. Firstly, design. Human-like approachable features build trust. The physical appearance user interface, and overall design of a robot can significantly impact trust. I know that Alexa is like a machine, right? And some people personally, it's on the table, right? If okay, Alexa was not built in a very nice looking way, and you wake up in the night and you just see Alexa, you would think that it's a ghost or something. So the physical appearance, user interface, and the overall design of robots can significantly impact trust. A well-designed robot that is intuitive and easy to use can foster trust, while a poorly designed robot can lead to mistrust. Like, for example, let's say Nigerians and their mentality, oh, you will see this Alexa looking all scary and everything. They'll be like, oh, it's my village people. Oh, is this. Oh, is that. Um, next is transparency. Transparency refers to the ability of a robot to transparency, clear decision making process, enhance confidence. Refers to the ability to robot to clearly to for robots to clearly communicate its intention. For example, for transparency, we have a self-driving car that, for example, a self-driving car that clearly indicates its intentions through visual cues like flashing lights or displays and can increase trust in its decision making. For example, I use my WhatsApp Meta AI. I don't know if that's but then if I say, oh, A is an apple, right? And my AI says yes, and maybe I have trust issues or something, I'll be like, oh, maybe you're just saying A is for Apple just to appease me or whatever. The AI or the robot or whatever gives like a detailed explanation of why A is an apple, why this is this, why this, and give more examples of what A is for. Oh, A is for an apple, A is alphabet, and whatever. Number 3, we have reliability. Reliability refers to the consistent and dependability of a robot's performance. So reliability, for example, let's say in a medical setting where the robot is meant to perform a precise and successful operation on a patient. So if that robot had performed that surgery on someone, though, and it was successful, and he has been consistently performing successful operations that can earn the trust of medical professionals and patients. We even have, for example, another example, a delivery robot that reliably navigates and arrives on time can build trust with customers. Ethics, privacy, security, and ethical behavior matters greatly. So a robot, let's say for example, a robot designed to assist with the elderly like Robert, which prioritizes gentle and safe interactions, demonstrate ethical considerations, and can increase trust. So just to hurry up, oversight and regulation needs. Oversight needs ensuring safety, reliability, and ethical use of robots, and then regulation areas, design standards, transparency, and accountability measures. So this what all this is basically talking about is it includes ensuring transparent and fair data collection, bias detection and correction, human oversight, privacy, security, and fairness. Bias and fairness in robotic systems. The algorithmic bias, flawed decision-making algorithms leading to discrimination. So this here it basically refers to discrimination embedded in algorithms leading to unfair outcomes. This can occur through maybe biased data, programming, lack of diversity, and complex decision making. Next, we have the data sets bias, non-representative training data, reinforcing social inequalities. The data bias occurs when training data is not representative, leading to models that reinforce social inequalities. We have design bias. Design bias bias is introduced during development and feature selection. Design bias occurs during development and feature selection, leading to biased models that perpetuate social inequalities. An example of the design bias can be facial recognition system developed with facial recognition system that only like detects white people, and there's poor recognition of non-white faces, perpetuating bias. And then for dataset bias, an example would be a medical diagnosed model trained on datasets with mostly male records and biased annotations. So that would result to less accurate diagnoses for women, perpetuating existing medical biases. Next on this thing is addressing bias in robotics. Detection methods, fairness audit, bias matrix, and diverse stakeholder testing. So just taking one from here, bias matrix, quantitative measures to detect and assess bias, such as disparate impacts and statistical parity metrics. This method helps to identify and express and address bias, promoting fairness and equity in AI decision making. We have mitigation strategies, diversing data sets, refining algorithms, and fairness by design. Diversing data sets is basically, I think it involves collecting data from diverse sources and populations to ensure data represent diverse perspectives, experience, and backgrounds, reducing bias by providing a more comprehensive and representative data sets. Regulatory implications, standard for bias testing, transparency, and accountability. So these regulatory measures promote fairness, trust, and responsible AI development, ensuring that AI systems serve diverse populations without perpetuating harmful biases. And then next we have ensuring trust and fairness. Trust, multifaceted and context dependent, fairness, extension for equitable robotic systems, and oversight evolving with advancing technologies. So in conclusion, trust, bias, and fairness are critical in HRI. In conclusion, trust, bias, fairness, and are paramount in human robot interaction. As robots increasingly interact with humans, it is crucial to ensure that these systems are transparent, explainable, and free from bias. Building trust in HRI requires addressing bias and fairness in robotic decision making, data collection, and algorithmic design. So yeah, thank you.
All right, thank you very much, Juliet. Though we couldn't follow, I don't know if it's from our end, but I noticed that your slides while you were sharing was just on the first slide. I don't know, probably maybe it's just from my end. But well done to you and to your group members for that presentation. Thank you so much for how comprehensive it was. So over to Mr. Gabriel, right? Please, sir, we want to hear your feedbacks on the presentation, and then we'll move over to questions.
Okay, I'll just give, thank you so much to both presenters. I'll just give one or two very general feedbacks. The first one was, like Mr. Ridwan said, I also feel the discussion was not deep enough, but that's not because you guys didn't do a good job. It shows that the topic, in my understanding, was open-ended, right? So it's like saying children and adults. You could say 1 million things about children and adults. Is it about the relationship between children and adults? Is it about how children should be? All sorts of things. So I think it's about the way the topic was crafted. But you guys both presentations touched some very vital issues in the discussion. Talked about issues of trust, bias, and fairness. The harms, the risks. Because when you start talking about oversight, the first thing that comes to mind, like I mentioned earlier, is what could go wrong, right? Why do we have to keep a human being to watch it? If our primary intention, sorry, forgive me, I have a 4-year-old that didn't go to school today, so in case you hear a kid playing around, it's just across the room. Sorry. Okay, so yeah, why do we have to now keep a human being to watch the system if our primary intention was to ensure that humans can go and sleep and still get the job done, right? So I've had discussions about they're not deep enough. These are the things that I thought we would discuss more today. That's why I left that area. What are the things that would prompt us to have to keep a human being in place to be sure that as long as a risk pops up, there's somebody that could turn it off. We see this discussion a lot with the autonomous weapon systems, human in the loop, and semi-autonomous systems. How much is a human meant to be involved, and so on and so forth. So from my end, those two presentations touched some very vital areas. I expected a lot more on the risk, what could happen when we use a robot, which is something I think you can't have a discussion about oversight if you don't have a discussion about the risk and transparency and accountability and all that, because these are the things that give the background need for an oversight. Okay, now that's more like a general understanding. Both presentations, with the first presentation, with most of the areas that are covered, I also talked about. I remember I talked about the absence of specific regulatory frameworks. And Mr. Rickman also mentioned the importance of sticking to industry guidelines. There are thousands of them, right? Many companies have now governance frameworks for whatever technologies, not just AI, but in many instances, robotics, right? Governments are beginning to think of governance frameworks, how to ensure that we use robots in workplaces in such a manner that certain harms are reduced or the impact on the society is highly reduced. There's also that talk about accountability frameworks, human oversight, the need for testing and validation. This is another very important thing we took from the first presentation, to be sure, from the perspectives of safety. How are we sure that this is safe? But sometimes we need to understand that testing does not really do the job in many instances, because and we've seen this in the case of Tesla example. Tesla has been, driverless car has been tested for the last 6, 7 years. But still, once it hits the road, the situation is different, right? You could simulate the environment like a pilot. You sit in a room and you learn how to fly an aircraft. But the moment you get into an actual aircraft, the cockpit feels different, everything feels different. So testing to a large extent just reduces the probabilities of self, of harm, basically, but then it doesn't conclusively solve the problem. Finally, I wanted to quickly mention something, just clarify something that Mr. Ridwan mentioned earlier. One of the things I mentioned was that a robot is a physical entity, right? I know there's been that confusion over years, and you're going to see there's a difference between a robot and what we generally call now bots, right? Yeah, it's a little bit of, it gets a little confusing. They are robots and they are software. They are physical robots, and the non-physical robots are the things that we call bots. We find them in digital and virtual spaces, right? So when people say I designed a robot to run, it's just I have a software that runs this thing for me. Like you hear guys in crypto saying I have a robot that runs my account. Okay, it's not physical. The idea is that it's a bot, it's a software. That's the difference I've tried to create. Many times you hear of non-physical robots, you hear software bots, right? So they are softwares. Then there's the RPA, the process automation, robotic process automation. It's another software robot also is used in industries, but it's a software that is used to automate tasks that are repetitive. If you have to pick something from point A and keep it point B 100 times in a day, you get a robot to do that. There's the arm that is the physical entity that does the job. Then there is the process automation is a process. It's more like a software, an algorithm, right? That's why I keep making that difference between the software and the hardware. Made in normal instances. In fact, the history of the word, the history of the word, the term robot is as far back as I think 1920. There's this guy, was a Czech from Czech Republic, right? And he used the word robota. Robota was for is it either Czech or Polish word for a slave, a forced laborer, right? Which in their understanding, your mind is shut down. You're taking instructions from the boss. So there's a physical being that takes instructions and carries it out, right? So that's the idea. Then you see in all the classifications, you see airborne robots, you see legged robots, fixed robots, mobile robots, and so on and so forth. That's the original perspective. But now we started using bots. You hear robots.txt that we use to prevent web crawling from websites. So we have to differentiate that in the traditional sense. You will hear the robot. The robot is normally in the traditional sense with reference to a physical being, right? But there are software robots which are not in the traditional sense robots, but they are more of software. They are more of the mental unquote element, the software, the automation element, okay, that helps in defining instructions for the physical structure to take. Okay, so this is, like I said, it's a little more complicated. As we get deeper, you get into some of these workflows and you realize that, okay, now this terminology we've been using it wrong. Many people still use that. That's also fine. I've seen in very high value papers, people still use the term robots to indicate that, but in its original sense, it was meant to talk about physical structures that are given instructions to carry out. So that's in a nutshell. I would like to take questions if there are any. I tried to answer the questions during my presentation. So I will see if there are any further questions that I could take. Okay. Thank you.
All right. Thank you so much, Mr. Gabriel. Yes, I just going through the questions. We noticed that you touched on some of the questions, most of the questions here. So please, we'll be taking live questions from the mentees. So please, if you have a live question, something that you would like to ask Mr. Gabriel for more clarity, based off of what you have researched and also based off of some of the information that has been shared in class, if there are peculiar questions you would like to ask, please, you have the opportunity to do so. But then I still would like Mr. Gabriel to highlight on a particular question here. The question is, what role should diverse stakeholders play in ensuring fairness and trust in the robotic systems?
Okay, yeah, thank you for the question. I think first of all, you need to understand who a stakeholder is at what point, right? A stakeholder is an interested party. Yeah. So when we say, I mentioned red teaming during my presentation, and red teaming is getting people from diverse backgrounds to get their opinion about something, right? So the understanding is that a lawyer would not think the same way an engineer would think. A male would not think the same way a female would think. A Nigerian would not think the same way a European would think. So this diversity is to ensure that in any society where, let's say, the technology is to be applied, there is an opinion, at least a representation of how that society thinks. Okay, if you're making some kind of robot for let's say the car manufacturing industry, okay, and you only get the engineers that build cars to sit and define things about the robot. When you're done, and then you send it out, you send the so-called the built car out, you're going to have questions from the users. They are not engineers. So their perspectives would differ. So in that instance, when we talk about diversity in stakeholder makeup, you need to get people, first of all, from as many areas of application as possible. Where are these people from? Where are these? That's why I usually complain that many times we have technologies that are going to be applied in Africa, and you don't have stakeholders from Africa. So you see cars, they build a Tesla. I heard someone has a Tesla in Lagos, right? And the question is, you don't have electricity to charge it. So if a Nigerian sat at the red teaming or at the stakeholder meeting to discuss that technology, that Nigerian's contribution would definitely be based on his or her own contextual understanding of Nigeria. Oh, this is going to have electricity problems. We don't have charging ports. We don't even have electricity. So can we have some, a more powerful battery system? The Chinese did this when they sent phones to Nigeria, especially. The first round of phones, the battery, once it rings 2 times because of the amount of energy it uses, after 30 minutes, the Chinese phone will go off. But now the things they build, they put more concentration on the batteries because they understand the perspective. How did they get this? They got a stakeholder from that society and asked, what are the problems that you think this technology is going to have when we send it? So the importance of having the diverse stakeholders is that you're going to get diverse information about certain contexts that may not be. You can't get somebody who uses a private jet to ask him questions about keke in Nigeria. How safe is keke? And the last time he used it was 25 years ago. That's if he has even used it before. He's going to start thinking, what is keke? If he has to give you an answer, he'll tell you it's okay, it's safe. So you get somebody that lives in some place in Nigeria where you have to use it every day, even though the person may not seem like a necessary stakeholder or a necessary addition to that red team. But the importance is that the person comes with that perspective. The more diverse the team is, the higher the probability that you will have sealed certain harms for specific societies. There are things that could go wrong in Europe, but they wouldn't go wrong in Africa, vice versa. Right? So if you get people from different places, you will see those loopholes. This is why it's important to have diverse stakeholders. Now, what role should they play? Those stakeholders should come with all they need is their background and opinions from the societies or from the groups that they represent. So don't fit into what the team wants. Come with. That's why the diversity is important. The role they should play is to contribute to give the perspective of the society they represent or the group they represent in the development of that technology. That helps the creators or the manufacturers to understand that when applied in this context, these are the problems that it's going to. Okay. And again, just to quickly mention that in ensuring fairness and trust. People, if you send me something that some kind of technology that I do not trust, the first idea would be that I was not there when you. Right? But if you tell me that, yeah, your brother sat down when I built it, when I built it, it increases the trust. So to a very large extent, especially Africans, we want to be sure that we have some kind of representation. Who was there when you did it? Is it my brother? Is it somebody I can trust? Not in the technology, but because there's a person that I can trust or that I believe in that oversaw the process, that was part of the team that discussed the technology. Okay. Yeah, I'm done. Any other question?
All right, thank you very much, sir. Sorry about that. I was muted and I was trying to unmute myself.
Okay.
All right. So so please, we're still taking questions. So our mentees, if you have questions, please, I would advise that you ask your questions. But then I want to ask a question, and my question, I think two, right? Firstly, it may not necessarily, the first one may not necessarily revolve around robotics in itself, but the question is, how do we push for advocacy within Nigeria for automation in that sense, using robotics and automation? For instance, I think just recently, Innocent Motors announced that they have started pushing out self-driving cars. And then we in Nigeria are still even very skeptical. A lot of Nigerians don't even drive Innocent per se. And I'm sure that's another issue, not just in Nigeria, but generally across Africa, where Africans don't really drive made in Africa cars and the rest. And how do we now push to the point where we now have enough advocacy where people can now begin to trust for self-driving cars and the rest? Because the basic or the typical African is still very skeptical about AI and the use of AI. So how do we get that kind of advocacy out? What will you suggest, sir? So we can't hear you, sir. Your speaker is muted.
Sorry. Yeah, I was saying, let me take that first and then maybe the second one. This is it's a very natural issue for Africans. We have a trust problem, right? And it's, first of all, it's cultural. Most Africans were brought up with human relationships, one-on-one. We want to see a man doing something, we want to see a human being sitting down and pressing something. So when you want to automate that, then the issue of can I trust who you automate, who you're delegating this to comes. It's a cultural thing. That's the first. So we need to go back to what cultures, what have we been taught in school? Many of us here, when we were much younger, we had situations where the parents would tell you, don't take anything from anybody else. It's a trust problem. It's a foundational trust problem. Secondly, the push for advocacy for automation, it's already happening. Nigeria is a not just Nigeria, but we are a very political system, right? We seem to politicize everything. You raise issues and they ask you, okay, so how do I pass this to the Oga at the top? You have to pass through. I remember when I handled a project for the EU on military technologies 2 years ago, and I tried to reach some top guy in the military, and somebody had to tell me, yeah, you have to pay me to. I'm like, I'm not compelled to do it. Trying to see how I can help. So if I have to pay you to do it, then I might as well just go elsewhere. I had conversations with top military officials from countries that are, China, Russia, Ukraine, US. These are guys that are just up there, but back in my own home country. And when I made the presentation, one of the first questions I had was, we didn't get feedback from your own country. I mean, and they they just made a joke and they laughed about it. Eventually, I had to explain that, yeah, I was unable to reach the person. So we have these political issues, right? These issues with not something I want to call corruption, but it's more of politics. We politicize things. So advocacy has to start from that perspective. If you have connections to a politician who's in a decision-making role, pass the message. Because we are going to get there. We either take those decisions or decisions will be taken for us. Again, you've given a very good example. Innocent Motors and people not trusting. If you are my classmate and maybe in the medical school, you and your classmates, you knew that you guys used to cheat to pass exams. When you become when you graduate, you both are medical doctors, you're not going to trust that effort. It's as simple as that. So we have that problem with ourselves. We do not believe that we can actually sit down and get things to work. So when somebody does, we begin to say, in this Nigerian system, how did that happen? There must be something fishy about it, even when there is nothing, right? So all these factors come together, they make it complicated. It's not just Nigeria. Africans are generally not culturally built to accept technologies at first times, right? Eventually, we get used to it. We are like, people you see go to the bank and queue to collect money when their ATMs there. Would you blame them? No, because the ATMs have functional problems that you put your card and it disappears and it takes you 2 weeks to go and fill forms, write applications to get an ATM card. So when there's also a structural, a problem with the system that deals with an opaque system, there's no transparency, there's no trust. So these are the main issues. These are the things that we need to fix. We need to look back at our cultural perspectives about technology, at our understanding of trust, at our understanding of society. It's, look at our whole structures. But from our very little points, if you have people that are in decision-making roles, reach out to them and begin the push from there. Advocacy will start from the universities. What are we teaching? What are young people learning in universities? Do they get to the point where they can accept, technologies? I had to tell students when last I came to Nigeria, I had to tell students, this is the assignment I'm giving, but I want you to do with a large language model, not just ChatGPT, use anyone. When you finish, I want to see. So people have to be encouraged at that level to use some of these technologies to begin to automate things. There are disadvantages, but trust me, there are lots of advantages. So that's what I think.
All right, thank you very much, sir, for that answer. So please, do we still have more questions? Do we have more questions from the mentees? So while we're waiting, okay, I can see Mr. Joseph.
Yes, good afternoon, sir. My name is Joseph Olag, and I would like to ask this question. I really appreciate your in-depth knowledge so far and the expression of it concerning the topic. It has been very, very informative. And my question borders on oversight and the fast development space and the fast development pace of robotics systems generally all over the world. So I would like to ask that, what would your speculations be? It is true that there are going to be systems that are going to regulate the extent at which robotic systems will grow. But then I am personally worried at the fact that human beings are fallible, and that itself is a problem on its own. So how do you think we can overcome that human fallibility that can occur in regulating the extent at which robotics will grow?
Okay. Yeah, that's a great question. I mean, human fallibility is always there, right? But there are things that humans are really good at. So the answer to that is what we usually call HRT, human robots teaming. There are things that humans are really good at. There are things that robots are really good at. If we work together, we optimize our output a lot. Human beings are good at making on-the-spot decisions, emotional decisions. Robots are more precise. 1+1 is 2. Humans would understand context even. Robots can execute faster. Speed, precision, right? So if we have teams of humans and robots working together, maybe we could have this in regulations. There was a proposal sometime last year when I went for a conference in Sweden. Somebody proposed, a professor, that there should be regulations that say, for instance, a company must have at least a percentage of the staff as humans. And for every department or for every 5 robots, there has to be at least 10 humans. Things like that to create that team to ensure that we don't completely delegate our capabilities to robots, right? Because then it's still going to be a problem. Human fallibility is the nature of human beings. There's no way we can take it off. In fully run human systems, there are still mistakes. But those mistakes will be minimal if we compare to, or the impact of those mistakes might be minimal when we compare to the impact of mistakes that are made by robots. Because robots deal with large scale, for instance, data, environments. Imagine one robot working with 100 people, and then that robot maybe crashes, or a robot car, put it that way, a self-driving car, runs into a market, right? The likelihood is that it's going to kill more people, because in a failed robot system, there is usually no kill switch. If a human being dozes off on the steering and wakes up, he has hit 4 people, he can press the brake, come out, or hits another car, come out, say sorry. Except in instances where the human being passes out completely on the steering, which is a different ballgame entirely. But a functional robot could get turned off, or there could be a virus in the system, and the brake pads are up, and it runs into a market and continues to kill people until it can no longer move, right? So we look at the volume of risk, the volume of output. What could happen if a human is involved? What could happen if just a robot is involved? So, like I said, human robot teaming, or human machine teaming in some instances, is very important, so that where humans are fallible, example, in sight or in precision, maybe you're trying to calculate something or it takes you a longer time, a robot can do that. But where there are things that only humans could do, emotional, and I was having a conversation before this about reasoning, whether AI can actually reason. It's an awkward discussion to have. So we need to look back at those. How do we bring the skills of humans together with the capabilities of a robot and put them together? So that's what I think. Does that answer the question, Joseph?
Yes. Thank you so much.
All right, thank you so much, Mr. Gabriel, and thank you, Joseph, for asking that question. So please, do we have any more questions? Don't have any more questions. So I think it's safe for us to call it an end to today's class. Today's topic has been robotics and oversight, and I want to say thank you to everyone. Thank you to Mr. Gabriel for your time. You've spent quite a while just explaining, answering questions, and just giving insights to the topic for today. So thank you so much to you, sir. Thank you to Mr. Ridwan in absentia. Though he was just here for a few minutes, in one or two statements he made, he was able to point out a few things which I believe was very beneficial, right? So thank you to Mr. Ridwan in absentia. If he does get his presentation through to us, we'll be doing well to send it over to the mentees. I think in light of that, I would like to say, do all enjoy the rest of your day, and goodbye, everyone. Oh, sorry, just before we leave, sorry, just before we leave, I forgot. It skipped my mind. So please, can we have our videos turned on so that we can take a quick screenshot? I had it in mind, but then it just quickly skipped my mind. So please, for those that are still on call, if it's possible, can we turn on our video so that we can take a quick screenshot? All right, thank you, Praise. Can we have more people turn on their videos so that we can take a quick screenshot and call it an end to class? All right, thank you, Mr. Daniel. Thank you, Mr. Joseph. All right, please, can we have more people? All right, please, do we have more people on call? Please kindly turn on your videos. Yes, we are done with class, so please, this is just the last function, just before we go. Do we have more people? All right, I think that's fine. Thank you so much to everyone. Goodbye, and like I said, enjoy the rest of your day. Bye-bye.